Good afternoon, and welcome to Cloud Slam 11 and Brocade's presentation, Preparing Your Data Center for Transformation to the Public Clouds. I'm Doug Ingram. I'm the Vice President of Data Center Products for Brocade. And in the next 45 minutes, we're going to be taking you through, as you move from server virtualization to public cloud environments, a step-by-step process to get there, and some of the important technologies that Brocade's introducing in this space to make that transformation and evolution much easier. So increasingly, as you all know, the world is becoming much more global in terms of our economy and in terms of the business environment that we all participate in. What that necessitates is today a much more agile and a much more flexible environment in terms of communications. There are multi-billions of new endpoints on the planet with smartphones and with iPads, etc., where we do computing from anywhere on the globe. And also the types of traffic that we're transmitting, be it simple text messages all the way down to downloading videos, etc., that are increasingly network bandwidth across the globe as we compute from anywhere. And increasingly, this means that the network as well has to go through a transformation and has a lot of different requirements. So as I said, the network is undergoing major transformation across the globe to meet those needs. And, a lot of those needs on the next slide here. Sorry, I'll give it a moment to load. So a lot of those needs here on this slide, where you see there are 30 billion devices that are going to be across the globe by the year 2020. That's smartphones, as I said, iPads, etc. And at the same time, today your servers are, if you're not in a server virtualization environment, usually achieve about a 15% utilization rate. Obviously, almost all of you today will have installed virtual machines. As you see in the next ad, almost 10 times the growth in virtual machines, really to do consolidation, reduce the power inside your data centers, and just to make the overall management environment simplistic. Unfortunately, virtual machines today aren't necessarily doing that. Oftentimes, your environment gets much more complex. Even though server virtualization may have solved some of the capital expenditure problems and made your capital expenditures less, it oftentimes means more management costs and complexity for you. So oftentimes you still see roughly 70% of your budget is consumed by operating costs rather than capital costs. And the other major trend that we have to watch is that storage is still continuing to explode. We're all data pack rats out there. We all are wanting to continue to store information, not just so that we don't lose anything, but also because increasingly our businesses are getting to the point where we want to mine that data. We want to use our business analytics software to get our key competitive advantages as to what may be some of the nuggets inside of the corporate information that we have to be more competitive in the marketplace. So increasingly, we hear about cloud computing, and really cloud computing is, as you start with server virtualization, about lowering CapEx costs, about improving server utilization, about scaling with your business needs, but also increasingly, and what it's really about is the on-demand services and capabilities. How can you, as an enterprise IT person or as a cloud provider, actually provide services to your customers on an on-demand manner, so that rather than an application from your customers taking days, weeks, or sometimes even months to actually be set up for your customers, they can actually go through a portal and they can set that up in a matter of minutes or a matter of seconds. That way they can do their job efficiently, and when they're done then, we can also take those services, those workloads and applications down. and then increasingly as well being able to charge on a pay-per-drink or a pay-per-use model for those services. So to that end, the Gartner group in March of 2011 presented a 5-stage path to getting to cloud computing. It starts with server virtualization, where you are doing the consolidation and capital expense reduction. And then moving to the next phase is actually using things like VM mobility, live migration, vMotion, etc., where you can actually start having virtual machines move about the infrastructure in a very dynamic way, so that you can either, let's say, use power cost savings. When you're not using all of your applications at night, you can reduce it to a fewer number of servers. Or during the day, if you need to spin up and take down VMs, you can dynamically move them across servers. Or increasingly doing virtual machine migration over distance, so that you can do business continuance, disaster recovery, or disaster avoidance types scenarios, so that you're much more mobile to protect and to expand your business on demand. The next stage of that is really building out a hybrid cloud, or a private cloud, which is to actually, inside your enterprise IT infrastructure, create a self-service model, so that your customers can come in, go through a portal, set up a virtual machine or application, and tear it down very readily. And that's really moving IT to a service-based model from where they've been. Also, again, with usage metering. The next stage is really the hybrid cloud, and that's where, in addition to what you have inside your own enterprise IT organization, you're also going to utilize some assets from the private cloud. You may do that to use some assets from the public cloud, You may do that to actually burst into the public cloud when you have excess traffic generated, or you need additional workloads for a particular application. Or you may, on a more permanent basis, have your private cloud in your enterprise IT infrastructure and use portions of the public cloud because they may have applications or platforms that you don't have inside your own enterprise IT shop, and therefore you want to make use of those additional resources in a very cost-effective manner. And then the last stage is the public cloud, which would then be essentially moving all of your data center out into the public cloud and actually utilizing all of the applications, or accessing all of the applications and workloads in the public cloud, and have nothing left inside your own IT shop. Obviously, this is kind of presented in stages. It's going to evolve for every customer differently. Some of you are probably already using services from the public cloud. Some of you probably already implemented at least some or major portions of a private cloud inside of your organization. So these can exist in different phases all at the same time. But it's kind of a model if you were going to say that you were moving your entire enterprise IT infrastructure into the public cloud, what would be the stages to get there? So if we look at the next slide here, in terms of stage one is the server virtualization stage. And as we're moving now into really the distributed virtualization, where we're doing VM migration using live migration, vMotion, etc. What happens is that the network tends to often be a bottleneck. The layer 3 boundaries don't allow VM mobility, etc. And so this large increase of east-west traffic that's going on inside the data center calls for a new type of network than the traditional 3-tier hierarchical networks that we've been building. And that network is what we call a fabric, and more specifically an Ethernet fabric. And what this network is it's a flat layer 2 network. It's highly resilient without being redundant. It's very low latency because in addition to carrying carrying data traffic, the network also wants to carry storage traffic and consolidate or converge the data and storage traffic onto one network. So a low latency guaranteed delivery network is imperative for that. Also, start to look at increasing bandwidth across the network. So not only in terms of larger speeds, but also as you do hit peak workloads in certain parts of the fabric at a given time, you want to make sure that that fabric can scale up and scale down using multiple paths through the network so that it's very dynamic and very efficient in terms of its resource utilization across the network. And then the last thing is, as I said earlier, it's a layer 2 network that's very inherently flat and very efficient. So let's talk a little bit more about Ethernet fabrics in general. So Brocade launched the industry's first Ethernet fabric. We announced it last May, and we started shipping products at the end of the year. It revolutionizes the layer 2 connectivity. It greatly increases the scalability of virtual servers because being a flat layer 2 network, virtual machines on any port can migrate to any other port with the network characteristics following the virtual machine, and we'll talk a little bit more about that in a couple of slides. It maximizes the network performance. It's a multi-pathing architecture through the fabric that makes it highly resilient and also maximizes performance. And the products were also awarded the most important enterprise IT product of 2010 by CTO Edge. So let's talk a little bit more about fabrics themselves. So as we look at the Brocade VCS technology, stands for Virtual Cluster Switching. That's the technology we use to build the Ethernet fabric. And what it does is it eliminates spanning tree protocol in your environment. So no longer do you have to worry about trespassing the layer 2, layer 3 boundary, which inhibits VM mobility. Also, what happens is when you eliminate spanning tree, if failures do occur on the network, we actually reconverge in much slower or much faster, times than spanning tree does. So we have sub-second convergence times versus multiple seconds when spanning tree is involved. It's also multipath, as you see in the diagram. So as we show here, from the virtual machine and the servers there to the iSCSI storage in this case, there are multiple paths through the network. And what happens is if one of those switches goes down for some reason, as shown here, automatically inside the networking, the traffic on that secondary link from the server to the iSCSI storage device is automatically rerouted through the fabric. So to this end, the fabric becomes auto-healing and non-disruptive to the traffic flows that you have going across the fabric itself. And then the other nice thing is when the switch comes back online, it automatically joins the fabric and all the communication is still flowing as it was before. All of this, all the Ethernet fabric is built on lossless, low latency DCB Ethernet for data center bridging, meaning that it's built for convergence. So not only does it carry your data traffic, your iSCSI traffic, your network attached storage traffic or NAS traffic, it's also built for fiber channel over Ethernet and also multi-hop FCOE. So a number of the beginning Ethernet switches in the industry were built as top-of-rack splitter switches whereby the traffic would go to the top-of-rack switch and split out either to Ethernet or into fiber channel. In this case, as you see in this diagram, you can traverse multiple switches here inside the fabric before getting to the FCOE storage, making it multi-hop or traffic through multiple switches. Another important element of the Ethernet fabrics is a concept we call distributed intelligence. So what happens in the Brocade Ethernet fabric is we have a fully distributed control plane. And what that means is that, first off, you can form this fabric in any arbitrary topology. Here we kind of show a star topology. You could do it in a full cloth network architecture. If you wanted to, you could even daisy chain it. Not necessarily that we would recommend that as a best practice, but the point is you can actually create these networks and these fabrics in any topology that you want. And what that means is, depending upon your application and storage requirements, you may want different topologies, you may want different oversubscription ratios in your network, And you can do all of that. And in fact, you can have multiple fabrics inside your data center built out differently because the application and storage demands required are very much different. One of the other important features of this is that with our fabrics, everything is self-forming. So when you cable a switch into the fabric, it comes up, it learns about the configuration from its attached neighbors and automatically joins the fabric. In addition, let's say you had a link between two switches already connected, a 10 gigabit link, so you have 10 gigabit of traffic going between the two switches, and suddenly you see on the management screen that that link is highly utilized. You can actually cable another cable between the two switches. That link will join the other link and become a 20 gigabit trunk between the two switches. And with our technology, that 20 gigabit link now, we will automatically load balance traffic across the two 10 gigabit links at roughly a 90 to 95% utilization rate. So you're going to get a very high utilized, kind of almost perfect link between the two devices with absolutely no configuration that you had to do via CLI command or a management screen. The other important feature about the distributed intelligence is the network-wide knowledge of all the members, devices, and virtual machines inside of the fabric itself. So in this case, we have a virtual machine with its configuration information, its port profile information associated to it. And that you see here on the screen with the configuration information linked to the virtual machine. That's actually stored inside of a database that's in the switch, and then that database is distributed across all the switches in the fabric. So then what happens is, in an open hypervisor manner, so this is not dependent upon any hypervisor vendor, that VM, let's say you dynamically move it to another portion of the network, the configuration information for that virtual machine automatically is inside the database throughout the network. And so when that virtual machine is seen on the new port, automatically the switches assign the virtual LANs, the QoS policies, the security policies, etc., to that virtual machine. And we call that the automatic migration of port profiles. So what this does is, in a cloud environment or a highly virtualized server environment, it allows full dynamic movement of the virtual machines across that fabric while ensuring that the network gives the proper SLAs to that application or workload. The other important thing is, as these environments scale, as you're building out to your private and public clouds, is that you're getting a lot of virtual machines. I talk to customers who have thousands of servers and 20 or 30 virtual machines per server. So we're talking, 20+ thousand applications, and your environment may not be that large, which is fine, because the Ethernet fabrics that we talk about can start with as few as 2 switches and as few as 16 ports per switch, or a 32-port fabric. So we can scale from 32 ports up to a very large multi-thousand port fabric. And in the future, we'll go to tens of thousands of ports inside the fabric. But the important thing here is that as these environments scale, you also want to keep them from an operating expense standpoint as efficient to manage as possible. And so we have a concept that we call logical chassis. And what it allows is, it allows that entire fabric of switches that are formed to be managed as one single switch. So all of the ports in the fabric will look as though essentially they were part of a large modular switch, accessed kind of by switch ID and port number, but managed as though they were one switch. What this means is that as you continue to add devices to the fabric, and as you continue to even then add additional devices, it's still managed as a single switch. And as I said before, when a switch joins the fabric, it automatically configures that switch, and it becomes a part of the fabric. And this also, with VCS, we collapse the access and aggregation layers inside networking, so that you're actually managing fewer layers inside of your data center. The next important feature of VCS and of our Ethernet fabrics is a service we call dynamic service insertion. And what this is the ability to insert services directly inside of the fabric without the application or the storage devices knowing it. So let's say, for example, that you wanted to insert an encryption device inside this stream of traffic that's going down to the storage device at the lower end. What you would do is you'd put the encryption device in the fabric. As soon as you do that, and as soon as you set the policies for that virtual machine to be encrypting, the network itself will take the traffic flows from that virtual machine. They will automatically reroute them to the encryption engine, where the data will be encrypted and then sent to the storage device, encrypted for data at rest encryption. So what this allows is it allows a full encryption service, as an example, to be inserted into the fabric without the application or the storage device knowing it, and yet all the data gets encrypted. It also allows us to not, we're not going to build all of these encryption services, firewalling services, extension services, etc. by ourselves. It allows us to incorporate the services from our ecosystem of partners into our fabric-based architecture as well. And it also really minimizes cost and physical moves, as well as application and storage reconfiguration. So let's talk a little bit about what the fabrics do. So I alluded a little bit to some of this earlier, but in a classical hierarchical Ethernet architecture where you have access, aggregation, and core, this is usually done with a spanning tree network with your layer 2 capabilities at the access layer, and then layer 3 up to the aggregation. And what that does is it really limits your sphere of mobility. So basically, usually your sphere of VM mobility is that very left-hand rack of servers there, and you usually can't migrate VMs to the other 3 racks of servers that you see in the diagram. Additionally, oftentimes with spanning tree protocol, you have active-passive links, where we show here the solid blue lines are your active links, and then your dotted blue lines are your passive links. So if one of those active links fails, then you have to fail over to the passive links. But essentially what you're doing is you're wasting your CapEx dollars for ports that aren't being utilized because they're just sitting there passive. So again, cost savings by moving to an architecture where all the links are active at all times. So when you deploy an Ethernet fabric, what happens is first you collapse the access and the aggregation layer into a single fabric. And now all of your top-of-rack switches join together to form a fabric. You can have VM mobility across all of the racks of servers on the bottom. You also, because it is active-active multipathing through the fabric, you have fully redundant routes. So if anything fails, the traffic just gets rerouted, and the fabric stays up and running. And as I said, that entire fabric is managed as one single switch. So whereas you had multiple switches that you were separately managing before in the previous hierarchical network, now you're just managing one switch here at the edge layer. And then that still connects up into your core routers inside of the data center that offer your connectivity to the WAN, and also advanced services like MPLS, VPLS, where if you wanted to connect fabrics over distance, you could run MPLS and VPLS services across your core routers and actually span the fabrics or have VM mobility across that infrastructure from fabric to fabric. There's another important fabric inside the data center as well, which we don't often talk about much in the industry, but it's actually a fabric that's been there for well over 15 years, and still today over 75% of the virtualized server environments run on, and that fabric is Fibre channel. It's the most widely deployed storage networking solution inside of data centers today, and it is a full flat layer 2 fabric, just like Ethernet fabrics. And as we are increasingly seeing, as we are building out private and public cloud infrastructures, there are new applications coming on board, like virtual desktop imaging, and also increasingly inside the data center, the use of solid-state disk. And the use of solid-state disk is also increasing the workloads for private and public cloud infrastructures. And so attaching that to fiber channel fabrics not only is a tried and true and highly reliable method for storage networking, but it's also just the same, that flat layer 2 network across the data center. In terms of brocade, we've been building fiber channel fabrics for over 15 years. A lot of the technology that we use to build our Ethernet fabrics came from our heritage of building the fabrics for fiber channel. It has a rich, robust set of features, including extending the fabrics over distance, integration of security, data movement and replication, as well as priority quality of service. And it has proven to be the foundation of shared storage for server virtualization environments, and we believe increasingly as well for building out private and public clouds, with well over 90% of the Global 1000 customers relying on brocade SANs. So as we've built out our Ethernet fabrics, we've taken all of the goodness from our fiber channel heritage in terms of our fabric knowledge and incorporated that with our robust hardened IP stacks in products like, for example, from our MLX and RX and SX, and combined those two together to form the Ethernet fabrics. And that's why we were first to market with Ethernet fabrics, as we could take existing technologies we had all the way down to our ASICs and put them into our new products and bring a rich, robust set of fabric capabilities into the market that will help you build out your private cloud infrastructures. So if we come back to the roadmap from virtualization to cloud computing, as you move from a distributed virtualized environment and move to a full public cloud, what you are going to need is very, very high performance, low latency networks. So not only are we doing 10 gig today, we're on the path to doing 40 gig interfaces and 100 gig interfaces. We've introduced 100 gigabit on our MLXE platforms. In addition, you'll want from the core out into the WAN, robust layer 3 routing, or even routing in between fabrics inside your data center. And the other thing that you're going to want is you're going to want to be able to take multiple data centers and connect them together to form a private cloud that's distributed across data centers. And when you do that, that's a multi-faceted problem or challenge that you're going to face, because not only do you want to migrate the virtual machines from data center to data center, you're also going to want to migrate the associated storage to that virtual machine to the other data center as well. So a lot of companies talk about moving the virtual machine itself, but they don't talk about moving the storage that's associated with that virtual machine. And because we have both the storage and the IP networking expertise, we can actually move the virtual machine, and for 25 years we've been moving storage over distance with our channel and SAN extension capabilities. So we have the capability to move both of them at the same time. So those types of technologies will help you build out the private cloud. Again, some stats from Gartner is that when you move from a single application, single server environment to a highly virtualized server environment, your I/O needs in that server go up by 25x. So suddenly the ports from the server into the network have to handle about 25 times the amount of traffic, which means increasingly the core of your network is going to have to become much higher speed than it is today. Then as you move from the private cloud to the hybrid cloud, this is really where you are starting to use services from the public cloud, either for burstiness of traffic or to get to other services that you may not have in your IT infrastructure, different platforms, different applications, etc. And here really this is a model where today you as an enterprise IT person may have even some of your customers using applications in the cloud, and you're not even aware that they're doing it. And that's really the things that as an organization we need to start watching, is that making sure that the data that's stored in the public cloud is secure, making sure that it's backed up, making sure that it has disaster recovery plans if needed, and making sure that you understand who owns the data, who has access to the data, et cetera. It's not to say that public clouds are bad, because they're not. It just means that as you're essentially extending your data center into the public cloud, you need to make sure that you have the necessary SLAs for that data. And this is kind of a brave new world, and we're still learning all of the business models and all of the contracts that are needed here. At the same time, open becomes increasingly critical, because as you're looking at different cloud providers, and if you want to start looking for, let's say, the most economical cloud provider, being able to migrate your applications and your data between them is going to become increasingly more of a critical requirement for you. So open standards and openness really starts to become a major theme as we move into this area of cloud computing. And then lastly, as we move from the hybrid cloud to the public cloud, here now we're really starting to evolve the business model to a full usage-based model where your customers are paying you for use, and on the back end you're paying the public cloud provider. You're evolving your business models to that full services-based evolution with very deterministic performance and service level agreements to make sure that your applications and workloads are getting what they need to run most efficiently. Also, location and physicality options become important. How fast can I get access to my data? Where's the data located, et cetera. And then also, we believe in this phase that as we get there more towards the 2020 area, that you will start to see consolidation of cloud providers. But for now, we still see a lot of regional cloud providers as well as some big global cloud providers. And just like in any industry, banking or whatever, we see as we move forward out there, that consolidation will occur. And then as we move beyond kind of the public cloud, and really look at leveraging the full advantages of public cloud, a whole new set of technologies, a whole new set of business models will evolve where there will start to be almost a monetary unit essentially for public cloud services, and then you'll start to be able to broker from cloud provider to cloud provider as to which provider you want to use to host a given application or workload. Again, standards will be very important here so that you can move between cloud providers, and also so that then you can arbitrarily move your applications where they're most efficiently, where they get the most efficiency within the cloud, all still ensuring that your service level agreements are met. So that's the roadmap all the way from server virtualization to public cloud computing. And from Brocade, we believe that as you move down this path, that certainly virtualizing your data center is the key launching pad for the cloud. It's your first step in kind of moving from one application per physical server to actually having pools of resources of compute, networking, and storage. Having choice is critical to any cloud solution. There are a lot of providers out there who will try to sell you everything from their own company. Just as in every business model transformation that we've seen in IT, oftentimes it starts that way because it can be very simplistic to deploy, but the models quickly move to best of breed, where you are buying the best of breed server, storage, and networking equipment so that you're getting the best solution for what your business requires. And an important building block there is forming those flat layer 2 networks, both for your data and your storage environments, that enable simplicity, efficiency, and most importantly, nonstop connectivity. Because as you are running 30 or 40 applications per virtual machine, you're interconnecting your storage, you have to ensure that fabric is up and running at all times. Otherwise, you're going to incur significant outage, and that's another area where Brocade has been known for over 15 years of building very highly reliable fabrics. Oftentimes today in our major banking customers, processing trillions of dollars of stock trades, for example, in a single day across a single fabric, that hasn't really gone down in over 7 years. So that's the type of reliability we provide to our customers, and we will continue to do that as we move into the Ethernet fabric realm. So with that today, I want to say thank you for joining us here, and I hope this was informative. Please, if you have any questions, we have people on Twitter who can help you answer them. Thank you.